Hello, everyone, and welcome back. We've had such an exciting day so far, and now I'm very happy to welcome René to the stage, Principal
Hello.
Consultant for Quality Management at Imbus Germany and Chairman of the Board of the Robot Framework Foundation. René is a driving force in test automation, developer of open source libraries, and author of the book Keyword-Driven Testing. And this is what we're going to talk about today. You will show us how keyword-driven testing with open source tools can boost test clarity, collaboration, and automation power without writing complex code. So I'm very excited to hear all about that. And I'll give the stage to you, René, and thank you for being here today.
Thank you, Elena. Okay, yeah. Hello together. I hope you had a good day. I think until now we are not seeing my slides, right? Yeah, I will go as Elena said. I will go through Robot Framework and Playwright. And Elena, I think my slides are still not up. Can it be? Okay, I will just continue, even so you cannot see my slide and I cannot do anything on that. Give me a second. Okay, I will talk a little bit about me. So as Elena said, I'm the chairman of Robot Framework Foundation, which is an open source foundation. And yeah, but still this is kind of distracting. We can see your slides. Okay, good. Okay, I cannot see them in StreamYard. Okay, good. Then if you can see my slides, then I can continue. Okay, so I'm a principal consultant at Imbus, and I'm the chairman of the Robot Framework Foundation. And as Elena also said, I'm open source developer or open sorcerer. I do multiple things, specifically, typically about test automation. I will go through keyword-driven testing today with you and explain you a little bit what keyword-driven testing is, how it works with open source tools, and give you an introduction of how Robot Framework and Playwright join a very strong force of open source tools. So let's start with the concept of keyword-driven testing. Keyword-driven testing is a testing specification methodology. So it's not a development concept like, for example, test-driven development or behavior-driven testing or behavior-driven development. It's specifically meant to write test cases, write automated, but also maybe manual test cases. So keyword-driven testing is made out of descriptive keywords, and a keyword is basically a test step or an action, and a keyword can be composite out of multiple other keywords. So you can have higher level keywords that are made out of lower level keywords. The idea is that keyword-driven testing is human readable, and it's very similar to imperative programming. So the idea of keyword-driven testing is to bring some advantages to your test specification. On the first hand, what I already said, like keywords can be made out of other keywords, so it's modular by concept. So the idea is that you can create modular test steps, that you can create higher level test steps, for example, like login user, and login user is made out of lower level test steps. It has many ideas of clean code. So it's basically clean code for testing. And with these keyword layers, it can bridge the gap between the very technical person, the test automation engineer, and the business experts that are very familiar with the test object. So by doing that, it can improve readability because it's compared, for example, to behavior-driven testing, has pretty short keywords, so more precise keywords than telling a lot. Because of these reusable keyword concepts, it increases reusability, and you can think about specific layers, specific libraries of keywords. I will show that later as well, so that the maintainability can also increase. Let's assume you have a login page, and back in the time, you type in your email address, your password, and then you click the login button to log in or to authenticate on the system. But nowadays, we introduced two-factor authentication, and we want to change the procedure. So the login process is typing in the email address, going on the next page, typing in the password, going on the next page, and then typing in the one-time password or your token. So the login process technically changed, but you're still logging in a person or a user. So a high-level keyword login user with some credentials can still be used as the same way. So from the business perspective, it's the same test case, but the technical implementation of that login user test step has changed. So this can be done in between these two keyword layers, and I will show you that as well. And keyword-driven testing also implements the concept of the generic test automation architecture that many of you may know from the test automation engineer syllabus. And keyword-driven testing implements that pretty well. I will show that as well afterwards. So the one tool that implements keyword-driven testing open source the best is Robot Framework. There may be some other corporate tools that either claim or actually can do keyword-driven testing, but on the open source area, there is basically Robot Framework. It's the one tool that does it really good, and there is no kind of competitor on that area on the market at the moment. Robot Framework is fully open source, and it's a generic automation framework. It came from the acceptance test-driven development. So it's a testing tool by origin, but nowadays it's also used for robotic process automation. So you can also automate business processes or connect tools with automation technologies that were not meant to be connected. For example, reading some information from an UI and sending it to a REST API of a different tool. For example, also in the, let's say in the accounting department, they need to send the salary to the employees, but on another tool you have, for example, like the travel expenses or so, and you want to connect these two tools, but these two tools do not communicate with each other. So you can use test automation technologies to connect that, and there is Robot Framework, also a tool used for it. A very cool thing is it implements keyword-driven testing and behavior-driven testing at the same time. So if you have Gherkin-style acceptance criteria, like given a specific precondition is done, when I do some action, then the test object should behave a certain way. If you have these kind of specification by examples, acceptance criteria for your user stories or your requirements, you can still implement these as test cases. But for more complex test cases, like system-level test cases, acceptance test cases, sometimes not 6 or 7 steps are enough to describe a full test case. So you need 20 or 30 steps, even business steps, if you have a complex business case and you want to test that. And you don't want to test that with Gherkin syntax because it becomes absolutely unreadable and pretty messy. So in that case, you can use keyword-driven testing. It's completely technology agnostic or independent. So Robot Framework itself, back in the days when it was open source in 2008, it was open source together with the Selenium library. So a Selenium-based keyword library, but this is not part of Robot Framework. It's a additional add-on to Robot Framework, as the Playwright-based library that I will show you today, or there is a 3270 host emulation library. There are doc testing libraries. I will come to that. So we have users that test web, some test app testing, some do SAP UI testing, some do embedded testing, and you can basically do everything with Robot Framework. And it's financed by the Robot Framework Foundation. The Robot Framework Foundation is a non-profit organization, and it's a registered association in Finland. That's the Finnish term of it. And I can't spell it, even though I'm the chairman of the board. At the moment, this is a little bit outdated. We have roughly 80 companies that are members of this association, and they are paying their membership fees every year. And with that money, we can then further develop Robot Framework. It was founded in 2015 by 7 companies, actually 7 competitors or 6 competitors and Nokia. And those 6 companies were using Robot Framework and wanted to ensure the future of Robot Framework, so they founded this association. If you are more interested, you can also go to the hyperlink or.robotframework.org and look up the association. Here you see some more known members, and you see here are, for example, no service providers except of Imbus, which is the company that I'm working for. You see a lot of user companies like Deutsche Flugsicherung, which is a German air traffic control, DB Schenker, Nokia, Fresenius Medical Care. All these companies are using Robot Framework massively in their software development lifecycle for testing, and they want to refinance Robot Framework. They want to put their nickel into the bucket so that Robot Framework can evolve further. We also see that here from the left, 2016, the download numbers per month of Robot Framework are massively increasing in the last years. We are now close to 4 million downloads per month of Robot Framework itself and installations, basically. So it's a very wide use tool. It's used all over the world, from Asia to the US and everything in between. And regarding the generic test automation architecture, where we have our definition layer, our execution layer, and our adaptation layer, Robot Framework basically takes care of the execution layer. So Robot Framework defines a specific specification language or syntax. Then you choose a tool which you want to use for your test definition, where you want to write your test cases in, for example, Visual Studio Code or other tools. And then you choose a technology that you need for your test automation. For example, if you want to control browsers, you can either go for Playwright, you can go for Puppeteer, you can go for Selenium, and then you use that tool, Selenium or Playwright, for example, as adaptation layer. And Robot Framework is the executor in between. So if we have a look to the editor, we see this kind of syntax. As you see here, we have these blue ones are our keywords like login user, and then it's separated by multiple spaces with our first argument, another space, and the second argument. Every line is another keyword call, so another test step. This line here, for example, select accessories, has 3 arguments, and these 3 dots are line separations. I will demonstrate it later live, and I can show you how the code completion works and so on. At the very bottom, you also see the login user code completion, and you see that this login user keyword at the very bottom is implemented by fill text on an element username with the argument username, and then fill text with the password. And then we click on the ID button login. These keywords can be implemented locally, where you also write your test, in case you have a keyword that you only want to use once, but for better readability of your test case, you want to maybe group some steps to a higher level step and use it then. Or you can extract these keywords to resource files or to other libraries. So here again, you see how you write these user keywords. This scripting language is a Robot Framework specific language, but the actual implementation of these keywords like fill text is then done in any programming language. For example, Python, which is the most common language in the Robot Framework ecosystem because Robot Framework itself is written in Python. If we now then have written our test cases and we execute Robot Framework, we call the robot command and tell, okay, robot, execute the following folder, and then Robot Framework will go through the folder and execute all the robot files that are in that folder. We see here, we had here some test cases, and once these test cases are done, we get some output files. So what we get here is an XML file that you then can use to, for example, import test results to test management tools or to some dashboards like Allure Report, Report Portal, to Grafana. You can use the output XML to publish them to X-Ray, for example. And you have a log HTML and a report HTML, which are directly reports that we also see later, where you see all your test steps, all your results, the timings, the log messages in these steps. And in the very bottom, then you can have the multiple technologies. In our case here, which you see on the left side, is a Playwright implementation. So we use here Playwright.js to implement different browser actions like click, type text, verifications, and so on, which I also show you later. Okay. One very important superpower of Robot Framework are these libraries. As I mentioned already before, Robot Framework was released initially with the Selenium library and some other small libraries like process library, you can start and stop processes. However, the Selenium library is made out of low-level keywords. So keywords like click with a locator, input text with a locator, and so on, open browser. So these kind of atomic commands are everything that you need to automate a web page. The thing is, because these commands are already given by the library, these 150 commands or so, you don't have to write some Python code. You don't have to write Java code and so on. You can just use the Selenium library and all these steps, similar to, I think, Selenite, which is also a very handy API to the Selenium WebDriver. And out of these click or type text things, you can then make higher level keywords and use these higher level keywords in your test. And Robot Framework, because of these possibilities that you can build more keyword layers, a big ecosystem has been evolved with multiple technologies. There are libraries for database access. There are libraries for HTTP communication, SSH. The doc test library, for example, is a library that was initially developed by DB Schenker and then open sourced. The GData virus scanner company, for example, they released a Windows UI testing library for Robot Framework. And you can just install these libraries and use these keywords to automate your stuff. And there are hundreds and hundreds of them in the internet, open source available. One of those, and one very interesting technology, is Playwright. We use today Playwright together with Robot Framework, and I will give you a very brief overview of Playwright. So Playwright is testing framework and testing technology to do cross-browser web automation. It's a successor of Puppeteer. Puppeteer was done by Chrome or by Google for testing Chrome browser. Playwright then is basically based on the Puppeteer code, but is possible or is able to do cross-browser testing with Chrome, WebKit, which is basically the engine below Safari, and with Firefox. This no trade-offs, no limits is kind of bullying Cypress because Cypress has heavy limits when it comes to web testing. It's good for some stuff, but it's impossible to do other stuff with that. So Playwright has no limitations because it's based on Node.js. You can get out of the browser. You're controlling the browser very well. Why did we now choose to develop a Playwright-based Robot Framework library when we already had a very popular Selenium-based library? So the thing is, Playwright uses a Chrome DevTool protocol. It's very close to the browser. We have huge possibilities to manipulate the browser, and it's super fast. So it was released in 2020. And as you may remember, in the spring of 2020, there was something else happening. We were all sitting at home, and I and some other friends out of the Robot Framework community had the ideas to contribute to these to this library, to this Playwright-based library. So we started in, I think, March 2020, developing these Robot Framework browser library as a successor of the Selenium library. And as you see here, in 2020, Playwright was still pretty small. Puppeteer, the red one, was the kind of the major tool in the node-based browser automation market. Cypress were really quickly catching up. In 2022, Cypress had already kind of overtaken Puppeteer with the download numbers as Node.js-based web automation tool. However, Playwright was catching up, and of course, Puppeteer, because it's a kind of grandfather or father of Playwright, decreased in download numbers, and at the same time, Playwright took over the market, and nowadays Playwright is definitely more commonly used than Cypress. And compared to Cypress, Playwright is completely open source, completely free. In Cypress, there is only a part of it free to use, and for other stuff you have to pay. So it was a good thing that we went on Playwright, and specifically because we saw it is way quicker. It's really super quicker than Selenium, quicker than Cypress and any other tools. And it is really open regarding the API. We have really good solutions for Shadow DOM. So if you ever have issues with web components, use Playwright. We have very good control about the browsers and the profiles. And we as developers wanted to play around with TypeScript, so that was a good opportunity for us. We are only using Playwright API and not Playwright Test, because Playwright Test is basically the competitor of Robot Framework, but I will come to that now. So on the left side, you see a test written in Playwright Test, and on the right side, you see the same test written in Robot Framework. As you see here, Playwright is based on TypeScript. It's async, and you have to write these await for every test step. A very cool thing with Playwright is that you can actually create test steps, which is very unusual for a code-based automation tool. As for example, most unit testing tools like JUnit, PyTest, and so on, they are not capable of logging actual test steps. They have a test, the test class, and it's logged. And if the exception happens, you have a stack trace, but you don't see the single steps that this test is doing, except you are logging it by hand every time. But what you can do with Playwright, you can create these test steps, and every test step that is actually called is logged automatically. You don't have to write something else like log open car configurator or log select motor or something like this. Okay, what you already see now here is the Robot Framework test on the right side versus the Playwright test on the left side is shorter. So it's more lean, it's more clear what are the steps, what are the values. You don't need these quotes and semicolon and stuff like that. Even more stronger is the difference if you look to the step implementation. So here we have this add step decorator that you can implement with Playwright, which means this login user is automatically logged in as a test step. And this login user is now implemented by technical things. So like a fill action on the element that is get by the label username, and there is a fill action with a password happening on the element that is get by the label with the word password. And you see this is pretty long line. What is actually happening is the same as on the right side. We call fill text on the username with the username and so on. So you see also here, you can do basically the same things as in Playwright, but it's shorter, it's simpler. Playwright has also, compared to other testing tools or other open source testing frameworks, pretty acceptable reports. I wouldn't say it's top-notch on the market, but it's good. You see errors, you see a stack trace directly in the report. You know where in your, not only the stack trace, but you can also see where in your code, so which code snippet caused a specific exception. For example, here, like as a timeout error. And you can also see which steps have actually been executed and which step is failed. And this is quite nice because you don't just have the test and that's it, and you have no documentation of the test. Compared to that, Robot Framework has also very good reports. These are those reports that are automatically coming already with Robot Framework. You have everything documented. You have all the functional test steps here, like open VSR Dream Car, log in user with the username and the password, configure new car, select base model. These are all the test steps. And the cool thing with Robot Framework is that you don't just have the steps that are actually that have actually been executed and the one that fails with the screenshot, but you also see the test steps that should have been executed if the failure would not have been happened. So for your documentation needs, these Robot Framework logs are pretty good because you can afterwards show a revisor or anyone else, okay, that is the test, how it should have happened, and here we got an error. So this is also pretty unique with testing frameworks, that you actually got logged even though the stuff is not executed. Okay. So another thing that Playwright brings, and you can also use with Robot Framework, is a trace viewer. And I will show you that later. If you once have worked as a web automation engineer with the trace viewer, you never want to change to a different tool than Playwright. I will give you a brief summary of which tools we want to use, or which tools I strongly recommend you to use if you want to start with that. So on the one hand, Robot Framework, of course, as a core component. As an editor, I strongly recommend to use Visual Studio Code with the extension Robot Code. Robot Code is a full-scale IDE for Robot Framework with step debugging, with code completion, with everything. And as technology level, we use Playwright in the end. And everything is open source, and we will have some time to demonstrate this. If you want to follow the demonstration as well, you can go to the GitHub page of Imbus, the company that I'm working for, and behind the QR code, you will find that as well. So I can show you, wait a second here. So if you go to the Imbus repository, where we have also some other open source stuff, you can find the Robot Framework tutorial EN. And here you have all the examples. You also have the slides of this current talk. And if you go down, you have installation instructions, how to install Robot Framework if you want to do a local installation, or you can use GitHub Codespace. If you have a GitHub account, you can use GitHub Codespace, I think for 50 hours a month for free. And with this GitHub Codespaces, you basically get VS Code with Robot Framework in the browser. And once you have started this GitHub Codespace, after some time with booting up, you will see something like this here. So running post create command, and that's it. And then you can start and go to your files and look to the Robot Framework code. So I will zoom in a bit. And as you see here in the tutorial section, test cases, we see we have a folder, simple Robot Framework syntax demo. We have our first suite. As we see here, we have these sections, the test cases section, and below this star test cases, there are 2 test cases, and everything that is indented are test steps. So we see here we have a log keyword. We also see some documentation about the log keyword. It explains what it does. And we have a word hello world. We can also write something else. So for example, here log to console, we see the code completion. we press tab, it tells me, okay, and which argument I am, and this is added later. So I can either execute Robot Framework by just typing in the robot command in the console with the path to the file. So in this case, for example, tutorial/test cases /00 something. And this will now execute this simple robot syntax demo. I will just execute the first one, and it has executed this one. And we had here, this will be added later, is basically the line that I have added here. In the end, we get 3 files. We get an output XML where all the stuff is logged. Wait a second here. So all these test steps are logged. Based on that output XML, we have a log HTML. Oh, why is it not working? The clicking. Command click. Doesn't want to open it. Okay. Then I will switch to my local repository and execute it. You can also execute the test just by clicking here on this check mark when you have already executed, or a play button, which will execute the same. And here I can now open the log in the browser. Wait a second. And I show you the log here. So what we see here, I also zoom in here a little bit. What you see here is our test case, is our suite, and we have here our test with our steps. I will go quickly to some other syntaxes. You can add variables in Robot Framework. You can have multiple sections. For example, you can import other libraries. For example, here the library string that brings more keywords. And for example, you could create a keyword like compare to uppercase strings, and that gets arguments. And we have our first argument, our second, wrong braces, second argument, and we have here, for example, like should be uppercase. So first, and we say should be uppercase second, and then we say, okay, should be equal as string, and here we have first and second. So this keyword can now be used. It got 2 arguments. So if we are in our test case here, this is German as an example. Compare to uppercase strings, hello world. And if I execute that, I will get an error because world is not uppercase. And that's exactly what it tells me here. World is not uppercase. If I make it uppercase, I will get the information hello is unequal world. And this you can also use to do web automation. So what we have here is this Playwright library, and we have here our new browser, new context, new page. And I will briefly show the Playwright library documentation. So if you go to robotframework-browser.org, you get the web page of the browser library, which is the Playwright-based library. There are also some talks about it. And if we go to the keyword documentation, with all Robot Framework libraries, you will get these kind of a keyword documentation. You see we have here a click keyword with the selector and the button. We have multiple things like fill text and so on. And with these keywords here, we can automate our tests. And these keywords I can also get here by just typing. So for example, if I say, what do we want to do? We want to, for example, get the style of an element, and then we can get the selector, and we can then compare the style. I will just make one thing here, tracing true, and I will show you the trace viewer afterwards. If you have just a test, you can also debug a test. So for example, let's say we want to make a breakpoint at the type text on the ID username. We could do that. Let me just check if this test is running. Yes, it is. So this was pretty quick. It did run. Let's change the selector, for example. Like we write something bad here. And instead of just run, which will just log the error and say, okay, here an error has happened after, I think, 10 seconds. I hope it's 10 seconds. Otherwise, we have to wait 30 seconds. Now, after 10 seconds, we got a timeout error because that element could not be found. However, what I also can do, I can say debug test. And if I do debug test, it automatically breaks on a test step that is failing. So in that case, you have, as if you would debug your code, you have a breakpoint there. You can access all the variables that are there. And you can also try out different things. So at the moment, now we are here in that breakpoint. There is an error that has happened. We have access to all the variables that are existing right now. And in the debug console here, we can try out stuff. So we have still our browser open here. So for example, I could use record selector. Wait a second. Record selector. It's not working. Wait a second. Let me check. I try it again. Debug go. Okay, not working anymore. Let's wait for the next release of the IDE. But what you can see is, wait a second, I can show you the step debugging, at least like doing step by step. Not sure why the debug console is at the moment not working. Normally you should be able to execute some keywords here. Nope, not yet. Not in the moment. The good thing is that the developer is pretty active, so I will report the bug, and I'm pretty sure that either I made something wrong or tomorrow it's fixed. So I will show one other thing. So for example, here you can see one test that is more keyword driven. So we have here used some keywords like login user with the set username, set password, click login button. And I can also click on the login user, and then the code is jumping here, and I can see set username is implemented in this file here by fill text. One thing that I want to show you is, let's go to the open. Okay, tracing should be set to true. And if we do that and I execute this test case, I will get a trace file together with this test case. And the trace file of Playwright is really cool. And I can show it with rf browser-show. Wait a second, rf browser show-trace. And then with a link to the trace file, and it's here in the results. I can copy the relative path, put it here. And that opens the Playwright Trace Viewer. And the Playwright Trace Viewer is really great. You either have, on the one hand, you have a lot of screenshots here. You can, let me check if I can zoom in a bit. So I can see the different steps here. I can go to a moment in time and see, okay, what action has happened here. And the very cool thing is I do not only see the Playwright actions, I also see my robot actions here, like the login user keyword. And before that keyword has been executed, the page looked like this, and after, wait a second, before and after it looked differently. So here, there was something written in. I also can see the source code where this has actually happened, and I can go down to the very basic Playwright actions that has happened then in the end. Specifically where an error has happened, for example, if, let's say, we close this one, again, the login user, set username. Let's say I have changed my locator here, and I execute my test case again. After 10 seconds, it fails again because the username cannot be typed. I see here what should have happened here at the bottom. And now I have my trace file again. And I can now see this locator.fill failed with the error like timeout 1000 milliseconds exceeded. The very nice thing is, though, I can now inspect these elements. So the test is over, but I can use the DevTools to actually click on the element, and I can see, let me just zoom in a bit. I can actually, after the test has taken place, can see what the actual ID was. So I can check this element had the ID input username and not the ASD inside. So even though the test is done, this trace log has logged the DOM while or during any action has happened on the page. And I also see the network communication that has happened between the front end and the back end. So I can really debug tests very well in this combination with Playwright and Robot Framework. Okay, so if you want to see more, you can also go to the Imbus webpage. We will show tutorials of Robot Framework as well, or have webinars where we have a little bit more time than here. You can also join the Robot Framework community if you want to learn more about Robot Framework by just going to robotframework.org. You can play around with some code examples here. You can run these code examples, which are really executing Robot Framework within your browser. So if you, for example, change something here in the code, for example, I'm again adding my ASD, and I run again, it will tell me, okay, the keyword login ASD user was not found. Did you maybe mean custom library login user or keywords login user? So there are two keywords with the same name. There are more examples which you can watch. There are documentations, there is guides, there's a user documentation, and there's a Robot Framework Foundation. If you are using Robot Framework already, maybe you want to consider to join. And if you scroll down, you also find here the community section where there is a Robot Framework forum or the Robot Framework Slack, where we have over 30,000 members in the Slack channel right now. And if you think Robot Framework is a nice tool and you want to learn more about Robot Framework, you also can take an exam or training, and then maybe an exam, the Robot Framework Certified Professional exam, which has been developed in cooperation with GASC and the Robot Framework Foundation. And if you go down here, you see there are some training providers listed, so you can search, for example, for your language, let's say Polish, and you will see that NICE project, for example, is giving trainings in English. Okay, so this is regarding the learnings of Robot Framework, robotframework.org for more information. And that's basically it from my side. And now, if we still have time, I would be available for some more questions.
Okay, thank you so much. So first of all, we got a comment saying the bug was already fixed, just not published yet. So
okay, who said that? Okay, yeah,
Daniel,
it was Daniel. Yeah,
yeah.
Daniel is the actual. I just saw it. So Daniel is the actual developer of Robot Code. So okay, good that he was here.
Yeah, he's here and ready to answer
said,
that question
at least,
already.
Yeah, I don't have to publish or open a bug report.
Perfect. Okay,
Nice.
so we have time for one more question. And the question would be, what role do you see AI playing in enhancing keyword-driven test automation over the next few years? I think AI is the big topic everywhere.
Definitely.
So I think that's an interesting question.
Yeah. So I think AI will have a pretty big influence on keyword-driven testing. The very good thing with Robot Framework is that Robot Framework is very widespread over the internet. So models like Claude, OpenAI, and so on, they all know the syntax of Robot Framework. So you can already now use Copilot for Robot Framework. You can use ChatGPT to maybe figure out some issues in your code. And it is very close to natural language. And this is good for the LLMs. And also Robot Framework has a lot of APIs where you can adapt LLMs to this API. What we, for example, did last year, and we talked about that on our own conference, and we'll talk about that on the upcoming conferences as well, is how you could use AI, for example, to review your test cases, to write your test documentation based on the keyword sequence, explain what the test is doing, for example, and also doing your keyword library reviews. So your keywords should, for example, following specific naming conventions. We always use the word, verify, not check, not assert. We want to use verify in our project. And what LLMs are very good in is finding synonyms. So if someone is writing a keyword that is called like check uppercase, the LLM directly knows, hey, you used a synonym, but in our glossary, we have defined we want to use verify for that. This is something where you can really get some support from the AI for reviewing.
So it's going to be really helpful in the future.
Yeah, definitely.
Okay. Great. Well, René, thank you so much for taking the time to be here today at the A4Q Testing Summit.
Thank you for hosting.
Yes, of course. Thank you. And for everyone out there listening, don't forget to vote for René on our A4Q Testing Summit website. And I hope you had a good time, a great night, and we can't wait to see you next year, hopefully.
Yeah, I would love it. Bye-bye.
Bye.
Software testers. Move beyond theory and master testing with the AI-powered ISTQB add-on practical tester by A4Q program. The ISTQB add-on practical tester by A4Q equips you with the theoretical skills and practical competence to truly excel. Learn how to apply black box testing like a pro. Estimate accurately, write flawless defect reports, and catch issues early. The ISTQB add-on practical tester by A4Q complements your ISTQB certification by turning knowledge into powerful action. Visit our websites and find out more information.